All right, so welcome back to Computer Science S75. This is lecture 4 on SQL. So what did we do Monday? Anyway, XML. All right, so good. So we talked about XML. Stands for Extensible Markup Language. And in one sentence, what is it or what is it good for? Yes? OK, good for structuring data in an easy way. And we looked at a few examples. We looked at how you might structure lectures, for instance. We looked at how you might structure pizza menu, or at least the beginnings thereof. And what are some of the design constraints on an XML file? What features can you have, or what features can you not have? How about someone else? Yeah?
Can only have one root.
Can only have one root element. OK, good. What's your name again? Lewis, OK. So you can only have one root element. You can have stuff at the top of the file like comments. You can have the XML declaration, which is optional. So there might be some stuff up there, and all of that hangs below the so-called document node. And that document node will become more relevant once we get to JavaScript. And even if you're already familiar with some JavaScript, you might know that there's this global object known as document in all lowercase if you've programmed in JavaScript before. So more on that to come. All right, so with XML, what are some other features of this markup language? Yeah, Axel.
I really don't know if it qualifies as a feature, but elements can have attributes.
OK, so elements can have attributes. So if you want to mark up some data but then associate some additional data with it, you can have these things called attributes. And an attribute is usually key equals quote unquote value. You can have multiple attributes on an XML element. You can have 0 attributes on an XML element. You can't have identically named attributes on the same element. And you have to have those attributes values quoted. But besides that, you at least have an alternative to this approach. What's the alternative to making some piece of data an attribute in terms of the design of an XML file? Yeah?
Making children elements within the element.
Yeah, exactly. Making children of an element is an alternative. So what's an argument for or against either of these approaches? Attributes versus children. Someone else. Otherwise, it's just going to be me and Axel tonight. Yes, Axel in the front.
If the data itself doesn't have a child, you might want to use an attribute.
OK.
But if it would have an additional child, then you would have to use an element.
OK, good. So if you think that your piece of data that you're representing might at some point need to be extended in the same way that a person was extended in our simple little Amazon purchase order example, whereby we added an initial, we added an address, then maybe it should indeed be a child element so that you reserve that flexibility for yourself. If instead you make it an attribute, that's pretty much the buck stops there. You can't further extend the definition. So attributes tend to be good for small pieces of data like IDs or short words or phrases. But you wouldn't typically put, for instance, a paragraph-long description of a pizza, for instance, in an attribute. You could, but at that point, it just doesn't lend itself to readability. Then it gets harder to have quote marks in the attributes value. So in short, this is one of those things that you just kind of start to know it when you see it. But when it comes to your pizza menu, recall that you're going to want to be careful with the design, because if you, for instance, create a pizza child, what was one of the downsides, even though we talked very briefly about it on Monday, what was a downside, arguably, of coming up with your own pizza element? Yeah, Jack.
Well, if you want to use the same thing to find a pizza element, to find, let's say, something in your sandwiches,
OK.
you're not going to be able to use the same thing because they're not the same element.
Exactly. If you want to find 2 different things in the file, you have to know in advance what those things are. You have to know that there's a pizza element. You have to know that there's a salad element. You have to know that there's a grinder element and whatnot. And so you've written now a lot of PHP code that has these keywords hard-coded. Now, that's fine if the pizza guy wants to add more pizzas to the menu or add more salads. But under what scenario would this design break? And by break, I mean you, the developer, have to go back to the pizza shop and change actual PHP code as opposed to XML.
They want a whole new item.
They want a whole new item. They want to sell ice cream or frozen yogurt or something that just wasn't anticipated by you. And so now you need to have a FROZN yogurt element and hard code that. So there, again, is sort of the manifestation of a poor design decision. And so we started talking about alternatives to this. And again, I disclaim there's no one right way. So you don't just have to copy what we started to do in Notepad the other day. But instead, we had category elements, and we had item elements, and we put the names for those categories and items, in that case, in the attributes, in attribute values. We could have done child elements, but at least there we had a more general design so that if you're writing PHP code, as you will be this week and this weekend, you can have a for loop or a while loop that's iterating over all of the item elements in the DOM, and you don't have to worry too much about whether it's a pizza or a salad because you can figure that out on the fly. So again, that's the thought process you should have when sketching out your own XML file. All right, so just a word on Project 0. So do bear in mind on page 1 of the project spec, as well as in the syllabus, is the specification for the course's policies on academic honesty. And they essentially boil down to this. You're welcome and encouraged to collaborate verbally with each other, stand in front of a whiteboard if you've gotten friendly with classmates, and talk through various design decisions. But when it comes time to write code, that should be done completely separately so that everyone ultimately is submitting his or her own project. So discussions in English good, in pseudocode good, in code bad. So just bear in mind that and read through it in more detail. All right, so that was XML. And what was the point of XML? Well, we'll see today an alternative to something like XML. We'll actually look at databases, and we'll look at a language called SQL, structured query language, that allows you to express yourself even more powerfully than you can with XPath, whereby XPath refers to what? Jack. Good, the PHP method for going through XML files and finding things. And just to be clear, it's not a PHP feature per se. That happens to be PHP's implementation thereof. It's a feature of PHP's simple XML API. But XPath is language independent. And indeed, there exist XPath processors for Java, for C++, for all sorts of languages. So XPath itself is a language separate from SQL, from PHP, from all of these other alternative languages. So we looked at a few features of XPath now. So we had these location paths that kind of feel a little like C:\/ program files or whatnot. So something's a little familiar to people. But what kinds of features does an XPath expression have, an XPath location path? We had these things called steps, and a step is kind of like the word implies. It allows you to start at the root of the document and dive in deeper and deeper and deeper, like taking steps into the tree. What else did steps do?
Yeah, you can also say which attribute in a certain step it should look for.
Exactly. If you want to look at an attributes value, like we did for the lecture number in our very short example involving a generation of an unordered HTML list of all of the lectures we've had thus far, we grabbed the lecture number attribute using @number, for instance. Or rather, that's what it would be in XPath. We happen to do that particular example in PHP, where we use the square bracket notation. So just realize we looked at a couple of different things. In PHP, we had the simple XML API that allows you to use the arrow operator, so hyphen, angled bracket, to step down into a child. And XPath allows you to do essentially the same thing, but more powerfully. It's a more expressive language than just go to a child or go to an attribute, because even though we just scratched the surface, recall that XPath has multiple axes. And an axis is something like child : or attribute : and those are generally not even written explicitly, just because it would be incredibly tedious to write XPath expressions with those long words. But there are things like descendant or ancestor or sibling, and those might seem kind of unnecessary right now, but indeed there are scenarios where it's useful. If you find yourself navigating, for instance, your XML file, and you're at a pizza element, and for whatever reason you want to get all of the other pizza elements at that same level in the tree, that level in the DOM, you can use the sibling access to just get all of those pizza elements, for instance. And more powerfully, think about it this way. When you're implementing your Pizza ML e-commerce site, and a user has added an item to his or her shopping cart, let's give some thought as to what should go in the shopping cart now. So the shopping cart is implemented in code via what PHP feature? Yeah, Jack. Isaac, yeah, the session. So the session is the super global that allows you the illusion of state with the user. And by illusion, I mean that even though HTTP is stateless, as soon as you stop requesting an HTML file because it's been downloaded, that's it. The network connection does not stay omnipresent. But there's this thing of cookies and this hand stamp metaphor whereby you are reminding the server who you are, so the server can in turn give you back the illusion of that same shopping cart. So what should you put in the shopping cart? A super global, like session, is just an associative array, which means you can put keys and values in it, which is actually pretty versatile. It means you can put pretty much anything in it you want. So what should you be putting into the session superglobal when a user says, give me a medium cheese pizza, submit, or whatever your mechanism is for getting that input from the user? What should you put in the session? Yeah.
Size, item, like
Good. So size, item, and what was the last? Price. OK, and what's your name again? Ben. OK, so size, item, price, or candidates. What else?
maybe the XML path to that particular element.
Interesting. So maybe the XML path to that element. Why would you want to store that, perhaps?
Because on my checkout page, maybe I actually want to show the item and the name and everything, and instead of just storing everything inside the session, which kind of takes up a lot of space,
OK.
a long name and a description, I could just tell my checkout page where to find it.
OK, interesting. So storing this location path, an XPath expression essentially, would enable you to query the XML file later to get back that same element, the upside of which is you're not storing all of these pieces of data like price and description and whatnot, things that you would want the user to see in their shopping cart, in their checkout page, for instance. So there's that optimization. At the same time, a location path is fairly long, so it's not necessarily super efficient. And what if, for instance, and this is admittedly a corner case, and it's something you can consciously choose to ignore, but you should at least trip over it. If you did store prices, as was Ben proposed, what's a downside there? Find a bug, even if it's an obscure corner case, in storing prices and names and descriptions in the shopping cart. Yeah. OK, so. Oh, interesting. OK, so if we're using US dollars, we have the $ symbol, which usually denotes a variable. Now, we can work around that by using, for instance, single quotes and so forth, but potential bug. Jack?
What if someone can go in and change their own session, like make negative money so that they're charging you to yourself?
Interesting. So what if a user could somehow make negative money by mutating the session object? So that's a good thought. In this case, because the session is stored server-side, they couldn't change the contents of it. They could spoof someone else's cookie by sniffing it wirelessly and then seeing someone else's shopping cart. But even in that scenario, they're going to end up ordering the wrong food, or they're going to be buying something someone else put in their shopping cart. So a good thought, but in this case, I think we're safe from that particular attack. OK.
Yeah.
Axel.
What if a user orders a pizza and then we store the price in the session, but then the price is changed
Yeah.
for whatever reason, and then the guy who actually buys the pizza pays the wrong price, a higher price, lower price.
Good. Good. So this is a legitimate corner case, and maybe it's not a big deal because if you're changing your price, you're either going to gain or lose a few cents. Maybe not a big deal. But in principle here, if someone knew your prices were going up and they know that the items are stored in the server side, the prices are stored in the server side session, if they just keep around that cookie that gives them access to that shopping cart, and they maybe pre-create a whole bunch of shopping carts using different browsers or whatnot, again, obscure corner case, they will get access to the old price, whether it's lower or higher. So not necessarily bad, but it's a little weird, right? Especially if your database is logging the prices people paid, even though there's not a database in this scenario. Now all of a sudden, even though your prices changed with the new fiscal year, July 1st of 2012, somehow your customers are still paying the old prices. So in short, it's just a little weird, it's a little inconsistent, and it's also just not necessary. What would be an alternative to storing these various pieces of metadata, or even storing something as long and as string-like as an XPath expression? What else could we put in the shopping cart, yet still enable this guy to sell pizzas and more? Yeah.
You could implement an identifier
OK.
for each item, so they would have like a number or a sequence of letters.
OK, good.
And then you would query to find that and essentially find everything.
OK, good. So what if we instead gave everything a unique identifier? Maybe it's a number, like this is item number 1, 2, 3. Maybe it's instead an alphanumeric string, like this is pizza underscore S for small underscore anchovies or something like that. Could go in a bunch of different directions, but just having this principle of a unique identifier is pretty compelling. Now push back on that. So have an argument among ourselves here. What's bad about that design? Jack.
If the person who's editing and going through all of these unique identifiers and decides that they want to change certain identifiers, or that they need to add something somewhere where it wasn't before, it becomes kind of messy for the person who has to implement new items.
OK, good. So what if the pizzeria guy, in short, needs to change things later, update things? You're assuming a lot of sophistication now from this guy who told you build him a site that allows him to edit it with TextEdit or Notepad.exe. And if you now have to put in your instructions to this fellow, well, you now have to make sure you choose a unique identifier for every one of your products. The question is going to be, frankly, what's a unique identifier? Which, even though that's, says what it means, to a layman, that's not necessarily the clearest statement. So this is also just assuming that the human involved is going to care about these details too. And frankly, a pizza guy and even a technical guy should not, and they should, for the record, they might not be mutually exclusive in this world. It's just not a detail you should have to care about, right? Why do I, the human, have to come up with these unique identifiers? So in short, whereas we get some nice flexibility of XML, and it's very low impact. We don't have to know anything about databases. We don't need a database server. We can run this on a PC under the desk at the pizza shop, so long as it has a public IP address. It's pretty simple, but we're paying a price for it. And even now, I don't think we've reached closure on what the best design is here. But again, these are the kinds of things you should be struggling with or tripping over, so that at least when you've designed your file, even if you know this is not perfect, this world of XML, at least you've made a conscious design choice. And as we've said, as I think we said earlier, anytime you have given some thought to a design decision like this in code or in XML or in HTML even, and you think, a sharp teaching fellow might think that I'm an idiot for having done this, but I really did give it some thought, just comment it, right? Put PHP comments, XML comments to just convey to us why you did what you did. And even if we disagree, at least we know you too were a rational being who gave this some thought. So that's as important as the decision itself. All right, any questions then on XML, XPath, pizza, or the like? All right, so let's try to solve some of these problems then today. Databases and SQL specifically. What is a database in layman's terms? Axel.
You could call it a big table with rows and columns.
Good. So big table with rows and columns, or at least that's one type of database that's been popular for some time. There's alternatives that we'll touch upon, but a table with rows and columns. So you might think of just frankly Excel or Apple Numbers. Any kind of spreadsheet program is effectively giving you a database. And in fact, if you've used Microsoft Access, that even looks like a spreadsheet, at least the UI part of it, and it allows you to store data in rows and columns. So what kinds of things might you store in a database? Well, what about orders from a pizzeria? Suppose we did go this route of having a unique identifier for pizzas, pizza _ s _ anchovies, or the location path, or a combination of fields like Ben proposed, pizza, quote unquote, and S, quote unquote, and anchovies, quote unquote, or the price. Whatever your approach, suppose that one of our columns represented that, whatever we're using to identify the thing in the shopping cart. And in the other columns, what might we have? What are the other pieces of information you probably need to remember when someone is buying something from a pizza site, or any site really? Yeah?
You would do the price. So if you query the database for the identifier, you could get back the price.
OK.
Maybe the name, maybe availability, if it's...
Great. Yeah, any of this metadata, again, quantity of pizzas bought or available, how many of these things are in stock, how much dough do you have, for instance, what is the unit price, or in the case of an order that a user has placed, how many pizzas did they buy? So in short, any of the data you might remember that you're throwing away right now for Pizza ML, because we don't require that you have a database, but we do require that you allow the user to pretend to check out. Once you have a database, you can also write to this storage mechanism and not just read as you are from the XML file. Oh, and just as an aside, so it's clear, one of the key motivations for XPath, realize, is that if you do take the approach that Axel proposed, or Ben proposed, or this approach of a unique identifier, realize that if you do have at least the first and third of those, if you have a location path or a unique identifier, you can use XPath, as we did, to home in on the specific element in the XML file that you want to get back, because you want to check its price, you want to check its availability, and so forth. So realize that the XPath function in PHP, even though it will return by definition an array of matching elements, realize that array could just be of size 1, which it will be if you've uniquely identified a node. So you can just grab bracket 0, for instance, of that array to get back the thing that you queried for. So that's where XPath's power comes from, so that you, the developer, don't have to write a bunch of nested for loops iterating over every possible element in the tree, looking, is this the one, is this the one, is this the one, is this the one, with ifs and elses and so forth. You can do it with XPath. So realize you have that expressive capability. All right, so what forms do databases come in? Well, what's CSV? What's it stand for, even? Yeah, Ben. Yeah, comma separated values. So this is really like a quick and dirty style database. So much like a spreadsheet has rows and columns, you can kind of mimic the idea of rows and columns in a text file, whereby every time you hit enter, you get a new row. That's pretty trivial. And every time you put a comma, you get essentially a different column. So if your first row has 3 commas, and therefore 4 fields, so field, comma, field, comma, field, comma, field, and the next row also has 3 commas, and the next one has 3 commas, even though the spacing might not line up perfectly, you will have effectively 4 columns in that CSV file. So you have the beginnings of a database, not unlike a spreadsheet. But there's some problems. If you're using commas to separate your columns, quote unquote, what's perhaps the most glaring deficiency of this representation? Yeah, Connor.
If any data has a comma in it.
Right, you're kind of screwed if your words have commas in them, because now it's going to be ambiguous to the program reading this CSV, or even the human reading this CSV file, what the comma represents. Is it a comma for grammar, or is it a comma for field separation? So it wasn't so long ago that people found a workaround for this. They have PSVs. Anyone know what a PSV is? Period. So not bad guess. It's not period, but it's pipe separated values. It's that vertical bar that you get by holding shift usually and hitting a key on the keyboard. So why did the world introduce PSVs? Well, frankly, to address this problem. Now, of course, there's a corner case here. What's the problem with PSVs? Yeah.
If anyone ever needs to use one of those.
Exactly. If you ever need a vertical bar, which is less common in fairness, but possible, especially it's right there on the keyboard, you're screwed again. OK, so then the world came up with TSVs. What are TSVs? Tilde, no, but good guess. I mean, frankly, we could make up our own file formats here pretty easily. It's tab separated values. So that is good in that at least you're not likely to have a tab in the middle of a sentence. But what if you're actually storing paragraphs? Or what if you actually are using a text editor, as some of you for programming might use, that doesn't really support tabs per se, because they get automatically converted to spaces? That system kind of breaks down. So tabs in general is a very fragile mechanism in programming in general. So that's not so hot either. So there are all these various formats. There are some workarounds. What you can actually do with any of these formats, commas, pipes, tabs, is you simply add some quotes to the situation. So you quote the entire column's value. So even if that value has a comma in it for grammatical purposes, you look to the quotes to say what is the string in this column, so to speak. Now, of course, what's the pushback there? Well, what if you want to have a quote in your quote? Well, then you have to introduce backslash quote mark. So we have a solution there. But what if you want to have backslash quote marks literally in your, well, then you do backslash backslash quote. But that might be ridiculous, but that's the world we're already in with programming itself. So just realize there are these various issues. But more importantly, what's nice about CSVs is, one, they're completely language independent. Doesn't matter if you're a Java programmer, PHP programmer, or whatever. They're compatible with any language because it's just silly text. You have to write a program that reads it. But once you do, anyone in the world, in theory, could use that library, and voila, you now have CSV support. Indeed, in PHP, they wrote it for us. There's a couple of functions, fgetCSV and fputCSV, that does all of the annoying parsing for you. So with fgetCSV, if you look up its documentation on php.net, you'll see that it takes an argument, which, for instance, is a reference to a file, foo.csv, on the hard drive, and it will parse it for you, top to bottom, left to right. And what it will return to you is an array of all of the rows. And then you can index into those rows because they themselves are arrays. So it returns an array of arrays where the big array represents all your rows, and each individual array represents all of the cells or the columns in that row. So it's nice. It just deals with all the stupid space issues, the pipes, the commas, the tabs. And in fact, even though it's called fgetCSV, you can override the default delimiter and tell it, don't use comma, use tab, use pipe, use tilde, use period, whatever you want it to be. So it's nice in that regard. And more importantly, there's fputCSV, which is compelling because it does the opposite. It writes CSV files, and it deals with the headache of figuring out what needs to be quoted, what needs to be backslashed or escaped, and so forth. So really handy. All right, then there's XML. Simple XML API actually has some faults. It's sometimes too simple. And for instance, case in point, the XPath function always returns an array, even if you know there's only going to be one node in the tree that has this unique identifier. So occasionally you'll run into just some, it's not quite as user-friendly as you would like, but it's definitely simple. An alternative to it is the DOM, DOM, Document Object Model API in PHP, which you're welcome to use if you really want. It's a little more sophisticated, and it's not necessary technologically for Pizza ML, but realize there are other parsers, so to speak. A parser is a program that reads files and does something with them. And then we have MySQL. What is MySQL? Yeah. It's actually not a query language. SQL is a query language, but what's MySQL? Yeah, so it's a specific make and model of database. So it's a vendor called MySQL that sells and also makes available for free a database server called MySQL. So it's software that you can download for macOS, Windows, Linux, and the like. You install it on your physical computer or your physical server, and it is just another service running on a port, listening in this case to TCP port 3306. Sort of slightly random trivia that you only rarely need to know. But it's just in that regard like a web server, like an email server. It's listening on a port, like we discussed in lecture 0. So MySQL, MySQLi, PDO, we'll talk about at least a couple of these tonight and on Monday. But there's built-in support in PHP for MySQL, which means just like you have these built-in functions for CSVs and TSVs and PSVs and XML, similarly do you get a lot of free functionality with PHP itself for interacting with a database. And what is this database, MySQL? It's essentially a super fancy version of rows and columns, but with multiple tables, multiple spreadsheets, if you will, so you can store lots and lots of data, as we'll start to tonight. So SQLite, anyone know what this one is? It's yet another alternative for a database. So SQLite allows you to use SQL, the structured query language we'll start looking at tonight in lecture and in section. And it lets you use the language, but without needing a database server, per se. A SQLite database is literally just a binary file, zeros and ones on disk, usually called something.db for database. And it stores rows and columns. How, you don't have to care about or know about, but it creates the illusion of rows and columns, even though it itself is just one big file. So it allows you to use SQL, as we'll see, is quite powerful, flexible, way more not necessarily user-friendly, way more expressive than CSVs and even XML files, especially when it comes to searching and such. But you don't need to figure out how to turn on a database or run a database or use the RAM for a database if it's a quick and dirty application or a small application with tens of users. This means you can package it all up in one folder, and you don't need any infrastructure beyond that. So some of the projects that I've written, I just reached for SQLite, where I want to use SQL because, as you'll see, it's a very powerful language. But I don't want to set up a database, set up a username and a password. When I give the code to someone else, then they have to set up a database, import the database. This way, you literally can send them a zip file with everything in it, so long as their server supports whatever language the project was written in, whether it's PHP or something else. All right. So for those less familiar, here's Microsoft Excel. And just to paint a very concrete picture, rows and columns, we're sort of talking about building up something like that in memory. And we can do it the old school way using a terminal window. So you might have dived into Project 0 already with SSH or with opening a terminal window inside of the appliance. This gives you a black and white or white and black interface, not unlike this. And MySQL, because it's a server that's listening on a port, you can talk to it, just like a web browser can talk to a server or an email client can talk to a server. So one way in which you can start interacting with MySQL is via this command prompt. So let me actually go over to the appliance here. Let me open up a terminal window. And what I'm going to do is, type MySQL, enter. And we'll see access denied. And let me make one tweak here just so that we can zoom in on this. Give me 1 second. So I can zoom in for us. There we go. OK, so access denied for user jharvard at localhost. Recall that localhost refers to the current computer. So I need to type a slightly more involved command, mysql-u jharvard is fine, and then -p, enter. Now I'm being asked for a password. As you may have seen in the appliances documentation, is that John Harvard's password is always crimson by default. So now we're at the point of where the slide was at just a moment ago. So now I can start typing commands, and this will very quickly get a bit tedious, but I can type show databases, semicolon, and here are the databases that come by default with a MySQL server. Information schema, MySQL, performance schema, test. For the most part, you should never, ever touch these databases. In fact, we typically configure the appliance in such a way that when you log into the database server with a GUI, as we'll soon see, called phpMyAdmin, we hide these by default because generally a developer should not touch them. They're used internally by MySQL with a couple exceptions. So there's nothing interesting here just yet, but I could start typing commands. Like I could start saying, if I need a database for lecture, I could say create database, and then specify what kinds of rows and columns do I want. Do I want numbers? Do I want letters? Do I want dates? Do I want times? We're going to be able to specify with much more precision the type of data we're storing, whereas CSV and XML, they're all strings in that case. Unless it, even though it might look like an int, it's still, quote unquote, an integer. So let's actually transition from this black and white environment, which while powerful is just not very user friendly. And let me open up something called phpMyAdmin. So notice here, I'm back in my Mac, but you can do this with any operating system, Windows or Linux or the like. Notice I've gone to http:// even though the browser's hiding that, appliance/phpMyAdmin. Now this will not work for you out of the box. When you've booted up the appliance, you can pull up this utility called phpMyAdmin using Chrome inside of the appliance by using what URL? If I open up Chrome inside of the CS50 appliance and I type http://, it's kind of spoiled by autocomplete now. Where can I go to see this? Localhost. When you're inside of the computer, as I am now, I'm in Linux, because that's the screen I've pulled up, I can call up localhost, and I'll get to the same place. I'm going to type in jharvard and crimson for my username and password, and I see that same UI here. The browser looks ever so slightly different in Linux than in Mac OS, but it's the same idea. However, on my Mac, I have instead appliance/localhost. How did I make that possible? Yeah, Axel. Yeah, etc hosts. So recall that there's this trick on Mac OS and Linux and also on Windows where there's a file on the system, and the project spec tells you how you can edit this for project 0 if you want, that allows you to specify a synonym for an IP address. So what I have done is edited etc hosts to say that this IP address, w.x.y.z, should actually be known as appliance. Why? Just more user friendly. It would be wrong for me to type localhost/phpMyAdmin on my Mac. Why? Yeah.
Because that would refer back to your Mac, which you don't want to do.
Exactly. Localhost, if I'm on my Mac, refers obviously to my Mac, because that is indeed the local host. And there is no phpMyAdmin on there, at least by default. You can install it. You can use XAMPP or WAMP or these various tools we talked about briefly in the first week as alternatives. But if you're not running it on your actual Mac or PC, that's going to be a dead end. So instead, we want to resolve it to the IP address. And as for the appliance, it's always going to change. But you can always check the appliance's IP address by checking the bottom right-hand corner here. And if you indeed have network access on your computer and all is well and nothing's broken, you will be able to visit the appliance via that IP address, which in this case is 172.16.100.129, but will be different for you. All right, so what can we do when we're in this environment? Well, let me go back to my Mac. And why do I use my Mac? It's just a little, either. They're functionally equivalent. So what can we do here? Well, one, now I'm being told there's no databases. But that's because the appliance is lying to you. We've hidden some of those more administrative type databases just so you don't accidentally break things or get distracted by things you don't care about. And I'm going to go ahead and click Databases at top left. And you'll see I'm prompted to create a database. I'm going to go ahead and create a database called jharvard_lecture. And notice that I'm choosing my username, underscore, and then the name of the database that I actually want, which is a common convention. And I'm going to click Create. And now notice what phpMyAdmin did. phpMyAdmin is coincidentally written in PHP. We don't care that it's written in PHP. That's just what the person who wrote it called it. It, however, is a GUI, graphical user interface, that allows you to administer a MySQL server. that could be running really anywhere. In this case, it's running on my appliance. But if you have a commercial web host, they might say, hey, we support phpMyAdmin. Go to something.com/phpMyAdmin. And then you log in with your commercial username and password in that case. So you'll see, hopefully, that this is just a nice way of navigating a database, especially once you start getting data in it, because you can just see it visually rather than in black and white text. And also pedagogically, we'll be able to see the features of MySQL thanks to some nice drop downs in just a moment. So this text here in purple and green, create database /jharvard_lecture /semicolon, that is SQL code. So if I instead go back to my terminal window, my black and white prompt from before, I could have finished this sentence. And I could have said create database jharvard_lecture /semicolon. And now notice it fails. Why? It already exists, right? Now if I change the name, like lecture 2, enter, that seemed to be OK. And notice the feedback is literally query OK, 1 row affected. And it did it really fast, 0 seconds. Now let's go back to phpMyAdmin. Let's go back to the home icon here. And voila, now I have 2 databases. If I want to delete it, I can go ahead and click here. And actually, let me go here. If I go to the Databases tab, notice I see my 2 databases. I can check lecture 2, click drop, which is the lexicon for removing a database. Notice it's yelling at me, are you sure you want to execute this command? And I am. And in fact, I'm going to do it the other way, though. I'm going to go here and say drop database jharvard lecture 2, semicolon, query OK. Back here, reload, and click the home icon. And sometimes it caches, so you have to reload. Oh, did I delete the wrong one? I did. That's OK. Here's how you rename databases. So now I'm going to go up to lecture 2. Now notice there's a bunch of tabs, and we won't play with all of them today. And for the most part, they're self-explanatory once you get comfortable exploring. I'm going to click Operations. And now notice I can just change this here, jharvard_lecture. And there's some other stuff. I can drop it. I can create a table in it. I can copy the database and so forth. But let me click Rename. And now notice, and this is where it's pedagogically instructive, even though we're using this user-friendly click and drag and interface, notice that it's telling us the SQL that you could have executed manually, so you can infer what the syntax is like. Create database jharvard lecture, drop database jharvard lecture 2 is the way it chose to rename it in this case. But it would have preserved our data if we had any. Yeah, Connor.
I notice all these commands are in caps lock. Is that case sensitive?
It is not. So even though you're seeing them in purple capital letters, that's typically a convention and it's a style thing that I would actually encourage you to adopt, because when you're reading your code in a syntax highlighted terminal IDE or code editor, or when you're just reading it as a human with eyes, it's just easier to see the SQL keywords as distinct from your own table and column names, which are generally should be in lowercase with no spaces or weird punctuation. Good question. All right, so let's now use this, but let's first motivate the problem somehow. I want to create a database for authentication. Recall that on Monday we looked at a number of PHP examples, one among which, actually, last week we looked at the login examples, where we used session and a cookie, and we remembered that jharvard was logged in or not logged in. And we went through a few iterations, login 1, login 2, login 3, and so forth. And none of those, though, used a database. At best, we used a constant and just hard-coded John Harvard's username and password. Not very scalable, not very conducive to having multiple users. So now we have a database. So now I have the ability to store rows and columns of information related to users. So that begs the question, if you were storing a database of users, even if you just think of this now as an Excel spreadsheet, what would the columns be in that spreadsheet that you would want to remember for each of your users, which is going to represent a row? So users go in rows, but what does each column represent if this is a spreadsheet of users? What kinds of fields? Yeah. Yeah, OK, so let's do that. So you might want a name. OK, so what else besides name? Location, phone number. What else? Remember that they need to be able to log in. Yeah. Password. So we need some kind of password in the system. So a few fields. So let's do this. Let's create the first of our spreadsheets called a table in a database. And to be clear, the fact that we're using a database that has tables means it's a relational database, or RDMS, Relational Database Management System is the buzzword there. And this just means you're using tables to store your information. And we'll talk in the future about alternatives to this, among which are NoSQL databases or object-oriented databases or document stores, which generally means you just store data differently. You don't use rows and columns. You instead store actual, say, PHP objects, which is a bit of an oversimplification, but that idea. All right, so let's call my table users. Again, I would say a common convention is use all lowercase, no special characters, and so forth. You could call it users. It's a little messy. I wouldn't call it users. I wouldn't call it my users. This is just bad. It will work, but you'll have to quote the string everywhere because it has a space. So in short, best practice would generally say use just lowercase, simple words that says what they are. Like don't call it table. Call it users. All right, how many columns? Well, let's keep this simple for now, and let's just go with 2 for the moment. Username and password, and we can always add to it later. So let me now click on Go or hit Enter. And now I get this field, this form that I can fill out. So I've not created the table yet, but I'm being asked a few questions. So let's go through this top to bottom. And here's where, frankly, phpMyAdmin's interface, it's a little ugly and it needs some work, but it's definitely more user-friendly than the command line for this particular task. So I'm going to give this field a name username, this one a name password. So I could call them whatever I want, but like with variables in a language, use descriptive words. And here's where now the dropdowns get a little instructive. Turns out I have a whole bunch of data types with which to define my schema. So a schema refers to all of the decisions we're about to make. What is the format of your table? So for a username, what do you want to go with here in terms of data type? Sorry? Yeah, so there's this thing here, variable char or varchar. This is probably the best candidate. And so let's put that atop our mental list, but let's see what else we might want to rule in or out. Text sounds like it's related, so let's maybe keep that on the mental list. Date, no. Tiny int, all these numbers are clearly wrong. Boolean, wrong. Date and time, wrong. OK, string. Looks like we might have to give this one a bit of thought. Char, varchar, tiny text, text, medium text, long text, and then the rest down there is some binary stuff. So you say varchar, variable char. Why, or what does that represent? What is a varchar?
Because if you specify that there's a 10 characters long, that it's not exactly the 10, maybe less than 10,
OK.
maybe 1 to 10.
OK.
If you choose char, and it must be 3.
Exactly. So a varchar, we're about to see, also requires that we tell it how long it should be maximally. So variable char means it's a string, but a variable length, but you have to give it an upper bound. So as you've proposed, if we say that this is a varchar of size 10, that means you can store usernames of length 1 or 2 or 3 or even 0 or 1 or 2 or 3 or 4 or 5, 6, 7, 8, 9, 10, but not 11 or beyond. But the upside of this is that if your username is just foo, 3 letters, it's only going to use 3 characters. And you're going to save those 7 additional characters, 7 additional bytes or whatnot. And so you have some space savings. Now for 1 row, who cares? For 10 rows, who cares? For a million rows, that's absolutely going to start adding up. But then char, contrary to the name, it's not a single char. You still specify the size. But a char field is a fixed size. So if you say 10, it's going to use 10 bytes. If you say 11, 11 bytes. Or maybe more if it's using 16-bit characters for other languages. So char, varchar, why would you choose one versus the other? Or why does char even exist if clearly it's more wasteful potentially? Connor.
I mean, maybe char if they're all going to be that length.
So maybe char if they're all going to be that length. So that's good. So even though users' names might vary in length, what might be a piece of data, even though we don't have room for it yet, that's a fixed length that people have? Sorry? So middle initial. If you just want one initial, a single char would do the trick. What else?
You wouldn't use a char for this, but the date usually has the same.
OK, so a date. Now it turns out there are date fields, but something like that, that's a known fixed length. Anything else? Maybe phone numbers, a little tricky with different country codes and whatnot, which could be variable length. But for US numbers, you can use 10 digits. For a state, you could maybe use 7 if it only has one zip code. So there's some optimizations there if you're not storing the hyphens and parentheses and things like that. But more compellingly, chars are also useful for performance. It turns out, and this is a lower level detail, but it turns out that if you do specify char, because you know the length in advance, the database can be faster at searching that. Because if you think of it just in the most naive way, if you have variable length chars in a column, the column's going to kind of look like this. It's going to be a ragged column, which means this string is this length, this one's this length, this one, it's kind of uneven. Which means how do you go from one string to another if you're doing something silly like linear search? Well, you have to know the lengths of each of those strings. And in the worst case, you have to search through each of those strings looking for the end of the string. If you come from C or C++, \0 represents the end of a string. You essentially have to look for that throughout the whole column, looking for the beginnings of new words. By contrast, if it's all chars and of length 10, the column now looks beautiful like this. Even if you're wasting some of those bytes, at least they're on the same boundaries, which means to go from this row to this one, or this string to this string, it's just plus 10, plus 10, plus 10, plus 10. So you essentially get random access like you would in an array. So that's the trade-off you have to make. And this is one of these non-obvious decisions. Just like in Project 0, there's no one right answer to menu.xml. Similarly, for Project 1, there's going to be no one right answer to how you design your database for that project. But these are the kinds of decisions you need to think through and make and sometimes struggle with. And even then, you and your business partner, if you go off after this class and work on something collaboratively, might not agree. But hopefully, you'll at least arrive at the table a little more informed than him or her. So char versus varchar. But it looks like we have 4 other options: tiny text, text, medium text, long text. So these are generally bigger. Whereby I think text is usually something like, it's big, 30, damn, I can't remember. It's like a few megabytes, I think, is for a field like that. So this is like if you want people uploading their resumes, for instance, or some long document, or something, or a huge HTML page that you've screen scraped or something like that. It might not be a few megabytes, I'm misremembering, but it's bigger than any of the fields we just discussed thus far. Generally, char or varchar are capped. Years ago, the cap was 255 characters. These days, it's 65,535 or 36 characters. Text is more than that. I just don't remember what it is offhand. But the documentation would have this. So the upside of this is that you can store big quantities of text. Well, that seems great, right? And they are variable length. So they're like big, big, big varchars. So now push back. If you just have this ability to just, let's use long text, because I have no idea how long someone's name is going to be. I don't want to choose some arbitrary cutoff like 10 or 32 or 255. Let it be as big as the database supports. What must the price be that we're paying to have that flexibility of being able to store names that are millions of characters long? What could it be? Connor, take a guess. Anything.
So are you saying like the downside to that?
Not so much. Oh, yeah, so sure, you can view it that way. There's some price we're paying, right? Because otherwise, if you could use long text for everything, it begs the question, why do any of the other data types exist? Now, we know why char exists, but what about varchar?
Just because like performance, I think it would just slow it down too much having that much data.
Yeah, so that's not bad. That is right. So it is actually a performance thing. Because text and long text and even tiny text, which is still big, it's just smaller than text, is meant to be pretty darn big for efficiency reasons when you store the database on disk. And this is not a design detail we developers have to care about. It's something the MySQL people have to care about. When they implement this database, they pretty much store the tables on disk or in RAM contiguously in this sort of conceptually this long column of text. But when it's a really long text, what they instead do is put in the column a pointer, effectively, to some huge chunk of text elsewhere. So in other words, the text, when it's really big, is not stored right there. So you can't just kind of hop around looking for it. You have to go here and then look over here. Back to the table, look over here. Back to the table, over here. So in short, it's just not as local to the rest of your data as everything else. So this actually has real world implications for caching. If you're familiar with L1 caches, L2 caches, some hardware type things, even in-memory caches that a database would have. In short, the farther away your data is, the less likely it is to be in RAM or in caches at any given time. So in short, this might just have a performance impact, as Connor proposed. And you might not notice it until you really have huge tables. But it's, again, one of those design decisions where for the courses project, certainly, you really shouldn't be dabbling in the text field unless you get to the point of uploading, large documents or screen scraping stuff or just big corpuses of text. Then it's compelling. All right, so that's username. Let's go with varchar. And oh, damn it. Now we have to have a conversation about how long a username should be. And this, too, non-obvious. But let's take a suggestion or two. How long should our variable length username be? Yeah.
32 characters.
OK, 32. Does anyone disagree? Frankly, 31 is pretty compelling. I don't know anyone with a 32-character username. Jack?
I would say 15 because I don't know anyone who goes that far either.
OK, 15. So I can actually think of some undergrads who have crazy long usernames just because their first and their last names are really long. So 15 makes me a little uncomfortable because now you're going to have like people with stupid usernames where they're like losing 1 or 2 letters. So maybe 32. But even there, it's like, who knows what's best? There's some sweet spot. But you don't want to err too high because you will potentially pay a performance impact. And not all that much. But it's just, we should try to keep it as close to reality as we need to. So 32, frankly, is not bad. Because any more than that, no one's probably ever typing your email address anyway. So 32 feels at least reasonable. All right, how about password? What data type should this thing be? Yeah, varchar is fine. And in fact, for most of our text fields, varchar is fine. And how long should the password be? I don't know, maybe 32 again. That feels long. Most people in this room probably don't have 32-character passwords unless you're super paranoid, like Jack.
No, well, I was just going to say that most websites say that minimum password length is 8, and then I don't know anyone who really goes beyond 16.
OK, so 8, 16. So somewhere in there. And I'll compromise this time. Let's say 16. Sure, that's fine. So your username's more secure than your password in some sense. But that's fine. So in short, just decisions you need to make. And I would generally, just as a matter of being anal, at least choose some standard numbers, powers of 2, or just heuristics so that you're not making judgment calls every which way. Just pick some consistent pattern. So frankly, I might even say 32 here just to be consistent. But I have no good argument for that other than the consistency. All right, let's see what else we can choose here to the right. So now in the top row, we have username. Bottom row, we have password, default. So it turns out that a database, unlike a CSV file, unlike an XML file, allows you to specify default values. Though in fairness, there's ways to do this in XML, but it's not nearly as straightforward as this. So should a user have a default username, whereby if they don't provide a username, my database will just put something there for them? Well, you don't have that much flexibility. You can either choose as defined, which means we can call everyone, for instance, John Doe, if they don't give us a username. Or we can just say, that's fine. Their username can be null. Or it can be a timestamp, which is just wrong here. So what's the right decision in this dropdown for default values for a username? This one, I'd argue there's a right answer. So don't guess wrong. Yeah.
I would use none.
Yeah, good. So right, if they're creating an account, they need a username. You can't just like give them a fixed name like John Doe, because it's only going to work for the first person. So in this case, it's none, which means they have to fill in this field. Yeah, Axel.
The length of the password.
OK.
Conventionally, you don't store the password in plain text.
Indeed.
You store it with some kind of encryption. And if you use, like, say, MD5, it's going to be 32.
I agree. So let's actually come back to this concern. Let's do it the sort of naive, clear text way then, and then we'll come back and realize, shoot, that was really stupid. And then we'll actually refine that field in particular. And it also allows an opportunity to edit the tables, which you can do after the fact. So we're not writing this in stone. And password default value, probably none either. We want them to give us a password as well. Collation is generally not worrisome. You'll see that this just has to do with encoding of characters. You don't have to even bother filling this in. The database will choose one for you. Don't worry when it says it's Swedish. Just happens that the original authors of MySQL were Swedish, and so the collation by default is a Swedish encoding set, but there is perfect overlap between that and English, so it's not a problem. You don't have to fret over that detail. So I've pretty much always left collation blank. Now attributes. This is unrelated for now, but we'll come back to this. You can have a binary attribute, an unsigned zero fill, or on update current timestamp. We'll come back to those. But there's some additional nice fields that a database can do for us automatically so we don't have to write it in code. Now on the right-hand side here, notice that we have, notice that we have a couple of remaining options. The first of which is null. Can this field be null? So this is distinct from the default value. Even though we saw null a moment ago, that just meant make the default value for this field null. This checkbox lets us make the decision, can it even be null, yes or no? So this is a good one to make a decision on. In this case, I think the story is the same. No, they cannot be null, so I should not check this box. But even if they could be null, I still wouldn't want a default value of null. But sometimes you might want to feel, what's a situation? Suppose we were making more sophisticated users that have more than just users' names and passwords. What field might be reasonable to have, but allow the user to leave it null? Yeah, middle name. Not everyone has a middle name. Something else?
Well, when you did the sign up thing for the sports, it's captain, and if you're not captain,
Yeah, exactly. So captain could be a field. It could be a Boolean field where you at least have a 0 or 1 there explicitly, or it could just be null or non-null. That would work too. So in short, optional fields where you don't want it to be the empty string. You don't want to waste any amount of space representing an empty string. You just want to say there's nothing even here. You can do that. Now index, let's come back to, but we'll have a discussion shortly about primary, unique, index, and full text. AI is completely non-descriptive, but it means auto increment. It's also inapplicable here, but we'll see when that might be useful. And comments is just for us humans. So at this point, I'm going to go ahead to the bottom of the box, and I'm going to say save and hit that button. And now notice what was just inputted to the database. Here again, could have done all of this manually at the black and white prompt. Just gets a little tedious, and frankly, I never remember the punctuation, so I still use tools like this. Create table, jharvard_lecture. These are backticks. So for US keyboards, this is the character usually on the top left of your keyboard near the tilde or on the tilde. That is MySQL's way of escaping things that might even have single or double quotes in them. So just realize that's a MySQL thing, these backticks. They actually have meaning. .users. So what is this saying? This is saying specifically create a users table in what database? jharvard lecture. Technically, you can omit jharvard_lecture dot. If you just say users, the database will assume whatever database we are in now. And recall that I clicked on my database at the top left earlier, so I've selected a database. So this is more verbose than it needs to be. Username now is of type varchar 32. The spaces are irrelevant. This is just a pretty printing thing, not null. Obviously, just reiterating what we said before. And password has the same constraints. Engine we'll talk about next week, but there are different formats in which you can store database tables. One of them is InnoDB. Another is MyISAM. Another is heap. There's a whole bunch of others as well. For now, know that it just has to do with performance and certain fancy features. And you can think of an analog as being Mac OS has HFS Plus, for instance, the Mac OS file system. Windows has NTFS or FAT32, FAT16. The database engine is similar in spirit. You can still store data in different engines, but they have different features. Just like you can store files on Macs and PCs, even though those file systems have different features. So we'll come back to that detail. All right, so now down here we see our little Swedish table that has usernames and passwords, but not, or the schema, therefore, but no rows and columns. How do I know that? Well, if I go up at top and try to click Browse, the GUI is just yelling at me, the table is empty. So clicking Browse gets me nowhere. So let's do this sort of in a cheating fashion. Let's click on Insert, and let's manually insert some users here. So for my username field, I'm going to type in a value of jharvard. And for the password, I'm going to type Crimson. And then I could give it another row and column, this ignore thing. This is, again, this has nothing to do intellectually with databases. This is just a GUI that's making it easier to put data into this database. So now I'm going to go ahead and click Go. Notice what just happened. I'm being reminded of the SQL that I could have typed if I wanted to. And what happened here is a new SQL command. We've seen create database. We've seen create table. Now we're seeing insert, which is definitely one of the most popular ones. Insert into jharvardlecture.users. And again, which of those words could we leave off? Quick saying. jharvardlecture and the dot, not strictly necessary. Open paren, username, comma, password, quoted. And in fact, the quotes are not always necessary. It depends on if you have special keywords or the like, but realize that phpMyAdmin always puts them for good measure. Then values. So values is a little cryptic in that it's not like there's no colon separating keys from values, but notice that username was first, comma, password. So similarly is jharvard first, comma, crimson in this case. So now let's do this manually. Notice that phpMyAdmin has a SQL tab up here, and that's indeed where we just were. Now notice by default, it puts in this query, select star from users where 1. This is another common SQL command, select, and it is what you use to search a database. So in this case, select star from users where 1. Translate that, even if you've never seen SQL before, just based on instinct, to English. What is this doing? Yeah, Connor.
Is it just saying select all items and users that exist?
Exactly. Select all users, all fields, or all columns from users that exist, because where 1 is just obviously true. So we can actually whittle this down. The where 1 technically doesn't need to be there. It's just pointing out that you can have conditionals in a sentence, kind of like a predicate that we had in XPath. So this is equivalent. And you know what's also equivalent here is select username, comma, password from users. That also is equivalent. Just star is nice shorthand notation, at least when you have a bunch of fields. So now let me click go and see what we get back. So now notice it's a little overwhelming in terms of the GUI. The only thing that matters is this temporary table that came back. What select does is it selects rows from your table and returns to effectively a temporary table. Now at the moment, this is really uninteresting because I selected everything. So it's equivalent to what I saw when I browsed this table a moment ago. Let's see it in another format just so as not to get too distracted by the GUI. If I go back to my terminal window, let me now do show, I'll do it in caps, show databases, semicolon. Notice if you forget a semicolon, you instead get another prompt. So you can then hit the semicolon there to make it behave. So now jharvard lecture. So I could do select star from jharvard lecture dot users where 1 semicolon enter, and there's my columns and rows. So this is what I meant by old school before. Like this really is ASCII art representing a database table, and this is fine for small data sets. This is a nightmare when you actually have lots of rows and columns. You just can't do it at the command line like this. But now let's trim this query to be a little more user friendly. I don't need this useless predicate. I also don't need this, or do I? Let's see, select star from users. So I haven't selected a database. So I can actually do this, use jharvard underscore lecture semicolon. So now notice database changed. I can hit up and down to go through my history. So now if I do select star from users, enter. Now it works. So why is this relevant? PHP is going to have the same exact mechanism where you first connect to a database like I did at the command line, and then you select a database, and then you don't have to worry about hard coding your table name, your database name all over the place, which gets tedious and also means if you ever change your database name because you move your code from one server to another, you have to change hundreds of lines of code potentially, or one if you factored it out to a configuration file. All right, so in short, where are we going with this? So SQL has a whole bunch of common statements. Create, which we've seen, haven't seen altered yet, kind of saw a drop because I did it manually to delete a database I didn't want. Select, we're going to see, we saw insert, we'll see update, delete, and then a whole bunch of others. But why don't we go ahead here, take a 5-minute break, and then regroup after that. All right, so we are back. So let's actually do something with this. So thus far, all we've done is play around with the database, both with the command line and the GUI. But let's actually try talking now to the database with actual code. So let me go ahead and open up a somewhat familiar example from a couple of lectures ago, namely these guys here. Let me go ahead and pull up. In the appliance, today's source code, and let me go into the login directory. And notice that we have these files this time. So a couple of these are familiar, home.php and probably logout.php. But we left off with 1, 2, 3, 4 last time. Now we have a few more variants, 5, 6, 7, and 8, which now actually introduce a database. So let's see what home.php looks like. Let me go over to my appliance, go into the root here, choose login, and choose home. And to be clear, now that you do have, presumably, or will have this week for the project, the appliance, realize that you can download all of these examples, put them in John Harvard's public HTML directory, or you can create a vhost like you're guided through for Project 0, and you can call it whatever you want. I called mine appliance, and you can actually play with all of these examples hands-on. All right, so you are not logged in. And does anyone recall how this file, home.php, knows that I am not logged in? Yeah.
Well, it looked in the session super global and looked after logged in true or something.
Exactly. So it looked in the session super global and it checked for a flag called authenticated, a key called authenticated. And if it's set there, that means the user is indeed logged in. All right, so let's go ahead and try logging in here. Version 5 has this problem, though, at the moment. So not bad. It's deliberately supposed to happen because I haven't provided any of the username or password or database details that we just created on the fly using phpMyAdmin. And you can kind of infer as much in orange. MySQL Connect, access denied for user quote unquote at localhost. So that already doesn't look right. Using password no, that doesn't sound right. So a whole bunch of problems, all of which can be traced back apparently to line 17. So let me go into the code in line 17 with Genie on login 5. And we'll see here in my text editor. Whoops, we'll see here in my text editor the following source code. So how is this starting? So first, I'm calling session start. Let me zoom in. What is session start doing for me again? Yeah, Axel.
It's starting the session, so it connects it.
I could have told you that.
Yes, but it connects the super globals and everything after you do that.
OK, good. So it's enabling you to access the super global, known as $_session. Let's be more concrete. What is it functionally doing underneath the hood? How is it achieving that end result? Put another way, how do sessions work? How do they get started? Huh?
I believe, I think something is sent in the, from when you request a page and the session start is included, the things you actually receive as like session ID.
Good. So calling session start ensures that the server will send, if necessary, a set cookie HTTP header with a phpSeshID cookie, whose value is a big random sequence of letters and numbers. And it will also ensure that if the user sent us a cookie : header, so not set cookie, but cookie : header, and that key value is present, then it will use that key value to look by default in /temp, where there are files named almost identically to the cookie value, which is, again, big random number, and will give me, the developer, the illusion of having access to the same shopping cart or whatnot that I previously had access to. Now, it's not a shopping cart here. It's just a storage for the authenticated flag, but same idea. All right, so the next line, connect the database, is the comment. So there's a new function here. And we can do better than this function, but it turns out this is one that you'll see fairly omnipresently in code online, open source code, and the like, called MySQL_connect. But we'll see better versions next week that will hide some of the details we'll now get our hands dirty with. So MySQL Connect takes 3 arguments, which you can see in the documentation if you pull it up on php.net. But I happen to remember that the first field is the IP address or the name of the server, which in this case is going to be localhost because I'm in the appliance and the database server happens to be on the same physical server as the web server. So it doesn't need to be one and the same, but in this case it is. My username, recall, is John Harvard. My password is Crimson. And what am I checking for here? So if connection equals MySQL Connect equals false. So some new syntax. So first of all, MySQL Connect is a function that does exactly what it says. It connects to the database using those credentials and that database server, localhost. What does it return? It returns a pointer to a connection object. Don't really know what that means yet, but it's some kind of reference to the open connection so that I can subsequently send commands to the database server. And then equals false, what is this here for? Well, if something goes wrong, MySQL Connect is going to return false. And it actually did. When we saw that big orange error message a moment ago, it was that was returning false. But why is it equals? Feels like a typo. Anyone know? Yeah.
I think 2 equals is the value and 3 equals is also the type.
Exactly. So this exists in other languages too, JavaScript, for instance. Because PHP is weakly typed, whereby you don't specify ints and floats and strings explicitly, you just use variables however you want. If you nonetheless want to ensure that you're testing a variable against a value not only based on its not only based on its value, like true or false, but also based on its type, so that it has to be false and it has to be a Boolean, use equals equals equals, or not bang equals equals. So use 3 characters instead of the usual 2. So in short, this is the identity operator. It's not the equality operator. It's the identity operator, which means test for equality and for type. Now, why is this relevant? Because if I just use equals equals and MySQL Connect returns 0, well, 0 is not false per se, but it is pretty darn close to false. And in fact, if you convert an integer like 0 to a Boolean, what do you get typically? So you get false, but 0 is not really false. And what if, even though this is not the case, what if MySQL Connect's purpose in life was to return integers? Well, then you couldn't distinguish the integer 0 from the Boolean return value of false. So this is a little weird in PHP in that you can return multiple data types, but it's a very common paradigm. And frankly, it's a little useful in that you can return one data type 99.9% of the time, like ints or strings or the like. But just in case something goes wrong, you can return a different type, like a bool, namely false. So this is this is different from a lot of languages whereby if you want to return a sentinel value to signal an error, you have to reserve certain numbers, for instance, or certain strings. So it's common convention in a lot of languages to return -1 to signify an error. The problem with that, of course, is that you're killing half of your address space. If you're reserving all 2 billion negative integers for error messages, I mean, that's a lot of potential mistakes, and you're killing half of your possible address space. So this is much nicer, even though it's a little bit messy. All right, so connection. Suppose it goes through. It doesn't return false. What do we have to do next? Well, you can kind of guess from this next line based on the example we did earlier. Select database. So this just chooses a default database, so we don't have to type the database name all over the place. So that's helpful too. And now notice I'm passing in 2 things, one of which I need to fill in the blank for, the other of which is a reference to the previous line. So now I'm going to go ahead and pass in the name of the database, which was what? Yeah, jharvard_lecture. And as an aside, this is not strictly necessary. If you don't bother passing that in, and you don't even bother retaining that value, MySQL Connect and MySQL Select Database will assume you want the most recently opened connection that was just opened. So that's a nice little convenience. But I'll go back to the original, slightly more rigorous way. All right, so now some of the code is pretty familiar, even though it's been a few days. If is set user and if is set pass, what is the implication? Well, that means that the user submitted the form. Right? And we had this conversation a couple lectures ago where this is one way of inferring that a form was in fact submitted. All right, what comes next? Well, now we have some SQL code. And there's a few ways to do this. And let me do it the wrong way first. So I'm going to delete what's here now, and we're going to do it more of a naive way first. So let me go ahead and do this. A SQL variable, and I'm going to just do select star from users, where user equals quote unquote jharvard. OK, so this line is obviously wrong functionally. Syntactically, it is in fact correct. But why is this obviously the wrong way to implement this? Yeah. Exactly. It's going to look for John Harvard no matter what, even if the user is David or Chris or Alan or something else altogether. So obviously broken, but at least it lets you see the SQL syntax a little more clearly for the moment. Now, what's the goal? The goal at hand is to determine whether or not the person who's trying to log in, their username and their password is correct. We can do this in a whole bunch of ways, but intuitively, if I can find the same user and password in the database, that's a pretty good start. Because if I can find that username and password, it means this person has typed in someone's username and password correctly, even though maybe it's not actually John Harvard. But that's a different problem altogether. So jharvard isn't quite right. So I could do this, $_post, quote unquote username. But there's a couple of things wrong with this. One, you can tell from the quotes, I'm kind of throwing off the balance here. Two, this is such an ugly looking variable, it needs to be explicitly interpolated by putting these curly quotes around it, or curly braces around it. Alternatively, I could do this. Let me try this another way. I could do quote unquote dot username dot single quote. So that's another way. And this is kind of a stylistic decision. Frankly, you see this a lot, even though I find it harder to read. So any problems with this? First, it's worth noting the single quote's important. In this case, it doesn't matter if I'm using double quotes and then single quotes, or single quotes and then double quotes, but anytime you are searching based on a string, you do need to quote things in MySQL. So this is important, having the single quotes around the username. So what else could we do here? Well, let me adopt this approach, and let me steal this code and move this up a line. So what about this version? So you might not have seen this function before, but it exists in a bunch of languages. sprintf, string printf. Notice that I can use printf like format strings, as I have here, as %s, as a placeholder. And then sprintf plugs in its second argument to that placeholder, and then optionally its third and its fourth and so forth. So why is this useful? Really, this is just an aesthetic thing for me. I actually find, at the moment, the third line in orange much more readable, that says select star from users, where user equals quote unquote %s. Why? Because I can kind of read it all in one byte, and then I can mentally go back and plug in the values to the %s. But I'm also doing something else. One of the stupidest names for a function ever, but what do you think it's doing? What's the point of this function call? Isaac?
I think it's to, if the username posts malicious code.
Yeah, so if the user somehow inserts malicious code, similar in spirit to the XSS, cross-site scripting attack we talked about earlier, albeit in the world of JavaScript and HTML. If they type in bad characters, maybe quotes, feels like quotes could be a dangerous character if I'm using quotes in my string. There's other things that could be dangerous. What if the user says their username is delete? That feels like it could be bad if I screw up with the interpretation of it. So in short, MySQL real escape string protects against a class of attacks known as SQL injection attacks. And we'll come back to those next week in our security lecture. But for now, know that this is good. And leaving this off is bad. Now, I say it's kind of a stupid name for a function because years ago, PHP had no notion of namespace support, did not have object-oriented support. And so the way in which they added more and more and more and more functionality to PHP is they arbitrarily use this underscore convention. So all of the MySQL functions begin with MySQL underscore something. Why they called it MySQL real escape string is ridiculous. There was a MySQL escape string function, which is apparently a little bit flawed. So someone else created a real escape string function. I mean, it's like a bad joke that's become popular convention. So anyhow, we'll do better than this next time when we introduce another API for database connectivity. But the point for today is that super important to do this. Otherwise, you put your data at risk to various attacks, among which include deletions or random insertions into your tables, or theft outright of like your users and passwords or hashes thereof. OK, so all three of these lines for the moment are equivalent, but the third one is the best because it has this additional security check. So let's go back to just the original and delete the other two that I prepared here. And let's see what I now do. Here is how you execute a command in PHP against this MySQL server. So when I used the GUI a bit ago, phpMyAdmin, which again is just an administrative tool for poking around a database, it's not something you're going to use in writing your project one or projects in general. MySQL query is the equivalent in PHP of my having clicked the submit button a few minutes ago. So what does it return? So it returns what's called a result set. And you can think of a result set as a collection of rows. It's a temporary table that is the result of executing that query, which in this case is select. So the temporary table I'm going to get back is going to have how many columns? Based on the orange query up there. Axel.
How many columns?
How many columns will this query? Sorry?
2 columns.
2. What are they?
Username, password.
Good. So even though I use star, the table itself, recall, that we made only has 2 columns. So the temporary table I'm going to get back by selecting from that table also has 2 columns. Now, how many rows is it going to have? Well, that depends on what the user typed in. Suppose the user did type in J Harvard and Crimson. How many rows, obviously, should the temporary table have? Just the one. Now in this case, it's coincidence. The temporary table is identical to the actual table, but now assume we're implementing Facebook and we have 500 million users, only one of whom is John Harvard. So then our temporary table is obviously much, much smaller than the actual table. So then it makes sense that we would be doing this selection. All right, so if result equals false, that just means something bad went wrong. How do I know to check for that? The documentation for the MySQL query function on php.net says upon error, this function returns false. So that's how I knew to check for that. And I'm using the identity operator again to be super correct. Die, sort of an unfortunately named function, but it's exit with a non-zero exit code in this case. So this just means something really went wrong. You should not typically die in production code. So if you're implementing a real website for real users, selling stuff, getting popularity, and so forth, you should not die. You should instead return some kind of error message to the user. But given that we're just trying to demonstrate MySQL here, and we don't want to get into views and MVC again and all of that, it's reasonable here to just say die with an informative error message. The user will see it, but it won't be very user-friendly. It's going to be text. So now we have to do something with this result set. So just like XPath, the function in PHP returns a node set, which is a collection of nodes, or really an array of nodes. Similarly, is in a result set, a collection, or really an array of rows from a temporary table. So I can count those rows with MySQL num rows. And if MySQL num rows, when passed that result set, returns the number 1, that means there's 1 row in it. So what do I then do? If there is, in fact, 1 row that I got back, I call this line MySQL fetch assoc. There's a few different versions of this. You can call MySQL fetch array. You can call MySQL fetch object. You can call MySQL fetch assoc. In this case, MySQL fetch assoc is associative array. So it's nice because it's going to give me back an associative array of key value pairs where the keys are, take a guess.
Username, password.
Correct. The column names, more generally, username and password in this case, and the values are what's actually in the cells. Yeah?
One thing, instead of doing the MySQL count rows thing,
Uh-huh.
can't you just in the SQL do limit 1?
Yes, I could do that. I could add limit 1, which is another piece of SQL syntax up here. However, it could still return 0. So I need to check for something. And so that's correct. If my database is correct, though, and I add something called a unique index, which we'll come back to, that should hopefully be unnecessary, but it's still good practice, still a good addition. So I'll leave it in there. All right, so now how about below this fetch line? So what do I have to do at this point? At this point in the story, I have presumably, at this point in the story, I have selected John Harvard from the database, but I haven't checked what? I only selected him based on username, so I have, right, so I still need to do this additional step. Just because J Harvard exists does not mean this person trying to log in is J Harvard until we actually check the password. So let's now do this. It's pretty trivial. So after I've called MySQL fetch assoc, I have an associative array for that row whose keys are the columns, whose values are the cells in that row. So if row, quote unquote, pass, oops, I got to change this because I chose different names before. So if row, quote unquote, password equals post, quote unquote, password, actually it was pass in the HTML, so I'll leave that be, even though I'm being slightly inconsistent here. What do I want to do? Remember that the user's logged in. And then all of these lines down here is just the cryptic stuff that we used last time to do the redirection of URLs, to redirect the user back to home.php. And that's it. If they're not logged in, notice that we have all of this stuff down here, which is just a simple form that we've seen a couple lectures ago. So let's see this in action and see if we got it all right. So let me go back to my browser, and let me reload login 5. Good. We got rid of the orange message. How? Well, we're actually connecting to a database properly. So it doesn't mean the rest of my code is correct. So let's try this. J Harvard with no password. Let's see if I can sneak my way into the site. Log in. Could not query database. That actually does not sound right. So what could have gone wrong there? Let's go back here. And what am I missing? J Harvard Crimson. Want to connect to J Harvard Lecture. And I'm saying could not connect to database. Why is that? J Harvard Crimson. Could not query database. That's a different message. Sorry. So we are connecting. sprintf MySQL select database, select users. Where? Oh, OK. So this is failing. And this is just my unfortunate choice of names earlier. What's the field actually called? Good. All right, so I made the mistake when I prefabbed the code. I called it user instead of username. So let's see if that now solves our problem there. Reload. We're going to resubmit the same form with just jharvard, no password. I ended up back here. Why? Yeah?
Because you weren't allowed to log in, so you were just...
Exactly. Right. These are super simple examples. The fact that I've seeing the form again means that I got it wrong. So let's try jharvard and some random sequence of characters. Log in. Still not working. jharvard and crimson. Log in. Nice. And so now I'm logged in. I can log out, and now I'm logged out. Back at home, I can try logging again. So let's prove that this isn't faked. Let's go to, where is it? Let's go to the appliance phpMyAdmin. And let's go to our users table. Zoom out a bit here. Let's edit jharvard crimson, and let's see the update command. So I'm going to change John Harvard's password to password, and then I'm going to click go. And notice now the SQL that was executed. Here's how you update a field. Update users, set password equals quote unquote password. All right, so slightly confusing, but this is the column name. This is the value. Where username equals quote unquote jharvard. And in this case, whoops. And, let's see. My cache expired. Let me do this again. Edit. We're going to change it to 1, 2, 3, 4, 5, so it's more explicit. So, and password equals password. So it is trying to change John Harvard's password to 1, 2, 3, 4, 5 for any row for which it is the case that username equals jharvard and password equals 1, 2, 3, 4, 5. So that's one way of uniquely identifying this row, hopefully. Unless we screwed up and we allowed two John Harvards who coincidentally have the same password in the database, in which case both of their passwords are going to be changed, which just is wrong. So we'll fix that shortly. All right, so what else can we do here? How can we improve upon this? Well, let me go back into the code here, and let me go ahead and open up login6.php instead. So in login6.php, notice that we have a couple of changes here. And what's different if we focus on this? Much of the code is the same, but what have I fundamentally done that's different? Yeah, excellent.
Well, in the SQL, you query for the username and the password at the same time.
Good. So in my SQL query, in this middle thing here, select one from users where user equals %s and pass equals %s. I need to fix this again and change user to username and pass to password, but that's not a big deal. So that fixes that same issue again. So selecting one. Why am I selecting one? Anyone want to hazard a guess at why I could take this alternative approach? What's an upside? What's a downside? If any? What do you like about it? Nothing? OK, what do you dislike about it? All right, no one cares about it. So take a guess. Like, think back to the previous example where I only selected based on jharvard. Then I did some stuff. This time, I'm selecting based on jharvard and crimson. And I'm doing less stuff, right? What do I not have to do in the case of this query? Yeah, I'm just saving myself some code, right? And this speaks to the beginnings of the power of an actual database server. You have the ability to do filtration and selection and conditionals. You don't need to re-implement that wheel in the code, in PHP code, or any language for that matter. So if you have the ability to do Boolean ands, as you do here apparently in SQL with capital A and D in this case, well, just punt to the database. Let the database figure out if John Harvard exists and if this is indeed his password, because that means I can write less code. And frankly, I'm going to assume that some professional database people at MySQL are smarter than I am when it comes to optimizing certain types of queries like comparisons like this. Now, granted, I still have to do the thought up front as to how long the field should be, what should the the data types be to kind of help the database be highly performing. But once I do those initial hints when configuring the schema, frankly, the database should be able to do this pretty fast if it's doing its job well. So in this case, I'm still escaping both just so that there's no danger. And I'm only selecting one as a slight modification here. Typically, what did we say is return when you do a select statement? You get back a temporary table inside of which is what?
The things you asked for.
The things I asked for. So technically, I'm not really asking for much now. All I want is the number 1 back from the database. So this is a minor performance improvement for at least a small database here. But if you think about it in general, if you were returning if you were selecting star and we had more columns rather than just username and password, and we had phone number and email address and GChat ID and all of these various pieces of data you might have associated with the user, why the hell do I need to select all of those pieces of data when all I want is an answer to the question, is your password correct? So the way to return that answer as efficiently as possible is just give me back a temporary table with 1 column and 1 row inside of which is literally the number 1 if my query is, so to speak, correct. Otherwise, I get back no rows, in which case it's clearly not his username and password. So a minor performance improvement for, again, small data sets. But the fundamental idea is that don't select more data than you actually need. And indeed, previously, when I did select star, I was being kind of lazy. I needed to get back John Harvard's password. But did I need to get back John Harvard's username? I mean, no, I already had it, right? I gave it to the database, so that too was just lazy on my part. So in general, avoid using star, because you're just going to waste time transferring information from the database to the web server, to your PHP code to access. And if you don't care about those fields, you should instead enumerate the ones you do care about one by one, unless you want them all back. All right, so the rest of this code is then thereafter the same. So let's see another variant of this that allows us to take it in a slightly different direction. So in this case, we're solving the problem that Axel referred to earlier. So this design we started with, it's kind of stupid. It's not incorrect. It's just not very good for security. And by that I mean my usernames are in clear text, and that's OK. That kind of is necessary. But my passwords are also in clear text. And by clear text, I mean if John Harvard's password is Crimson, what do we see in the database? CRIMSON. What does that mean? It means if someone's looking over the database administrator's shoulder, he or she sees that same password. It means if the database is somehow compromised and a bad guy physically walks up to the computer and copies it, or somehow someone on the internet steals that database, or someone on the internet executes a SQL injection attack, inside of which is a select statement. So now some random kid on the internet has selected all of the users and passwords on my database. In short, not so good if by losing the database table, you're also losing your users' passwords. So what's an alternative? So you proposed what before, Axel?
You can one-way encrypt the passwords.
OK, what does it mean to one-way encrypt the passwords?
Well, it means to scramble the letters and numbers in a way that you can't engineer it backwards.
Good. So a one-way hash, as it's generally called, is kind of like encryption, but it's encryption in one direction. And it's encryption in the sense that it does scramble the input. So your clear text becomes some kind of ciphertext. But it's one way in the sense that you can't undo those effects. So if my password is CRIMSON for Crimson, what's stored in the database is going to be some crazy looking sequence of characters. It's not going to be Crimson. The only problem with that is that no one now can see what my password is. So it feels like this is not the right solution, right? If I am not storing Crimson in the database, I'm instead storing a hash of it, a mutation, a scrambling of it somehow. And yet me, the human, I know what my password is. I don't know what that random series of text is. Only the database does. How do I subsequently log in after my password has been stored in this scrambled fashion? Yeah. Yeah, exactly. So there is a solution here. So when I create my account, when I register for an account, they don't store the database Crimson anymore. They instead run it through this one-way hash, which is just a function that returns some random characters. Then they store that string in the database. So what does that mean for subsequent logins? Well, I obviously don't know what that random string is, or that seemingly random string is, but I do know that my password's Crimson. So all you have to do is those same mathematics again. The next time you try to log in, take my password Crimson, which I typed into the post submission, encrypt that, or hash that, so to speak, and then compare what? Compare that result against the result you stored in the database, and if they match, then it must be me. Now, small white lie, it's possible with various hashes that two people's passwords could hash to the same value. So if my password is Crimson and your password is 12345, in theory, because of the way hashing functions work, the random sequence of characters that's stored in the database could actually be identical. So what does this mean? This actually means that I could log in with either Crimson or with 12345. The only catch is that I have no idea mathematically what else hashes to that same value. So the reality is almost all of us who have accounts on sites on the internet, odds are you don't just have one password. You could have maybe 2, maybe even 3 or more passwords. It's just you have no idea what they are. And you could try to figure it out. But if passwords can be 12 characters, 16 characters, and they can be letters and numbers and punctuation, that's going to take a lot of time to brute force figure out what your other possible passwords are. But this is just the nature of a hashing function. So how are we doing it here? In orange here in the middle, almost the same code, but notice that I'm practicing what I'm preaching here. I'm comparing not just the username with %s, ignoring the misnamed user and pass field, not just comparing the user field, I'm also comparing the pass field, but I'm not comparing the pass field against %s. What am I comparing the pass field against? Capital letters, PASSWORD, open paren, quote unquote, %s. So it turns out that MySQL, as a database server, can do more than just store rows and columns. It can also allow you to call functions. And in fact, databases often support what are called stored procedures, whereby you can write your own custom functions, store them in the database, and then call them. Just so happens that MySQL gives you one such function for free called password, which does exactly this one-way hashing that we've been talking about. There are other functions like average and sum and count and various useful things for a toolbox to have, but this is one relevant to passwords. Now, there is a catch. This exists, but does anyone know what the caveat here is? Yeah. You can reverse engineer it. It sucks is really what it boils down to. The password function is the right idea, but not very well implemented. And in fact, with relatively little effort, can you brute force the password function and figure out alternatives to those hashes so that you can figure out effectively how to log in as someone else. So there's alternatives. And Axel mentioned MD5 before. There's SHA-1, there's MD5, there's SHA-256, SHA-512, and yet others. The reality is that MySQL does not have great built-in support for this kind of hashing. There's faults in most every one of the algorithms that it does support out of the box. So generally, even I, in recent years, have taken to using third-party libraries and doing this in code. phpMyAdmin, P-A-S-S, is an alternative. It's a freely open source PHP library that actually does the mathematics for you. So you call an actual PHP function, and you pass that string into the database rather than letting the database do it yourself. Arguably, this is better too, because then if you ever do change from MySQL to Oracle or PostgreSQL, you're not relying on database-specific functionality. You're only calling the most basic of SQL functions like average and count and summation and so forth. So your code is arguably a little more portable. But this is one of the minor headaches of MySQL, is that this function, perfectly named though it is horribly implemented. So just don't use it. But also don't store things in clear text. Your better bet is using a library in PHP or whatever language you're writing in. But the point ultimately is to hash it. All right, any questions? All right, so one last variant of this. That was 7, and here is now 8. All right, so in version 8, no, I'm not going to show you this one, because this one's just similarly not so great. Let's do this instead. All right. So MySQL. Unfortunately, documentation, not so good. It's correct and it's complete, but it's not nearly as user-friendly to navigate, to be honest. So when it comes to like looking up things related to MySQL or SQL, to be honest, I think you'll find that Google and various free websites, some of which we've linked on the resources page on the course's homepage, and will point you at as needed in the PDF of Project 1, are probably better resources. But if you ever need an authoritative answer about MySQL, realize that the manual, this is the place to go. And this is, in fact, useful for things like how big is a int field? How big is a big int field? How big is a date field? How big is a text field? And so forth. When you want definitive answers to those kinds of things, best not to trust random people on the internet, but to actually go to the official documentation, much like you would for various PHP functions. But we glossed over one important and compelling detail earlier in one of those drop-down menus in phpMyAdmin, namely primary key, index, unique, and full text. So in our users table, we have username and password. Which of those should be by nature unique? And by unique, I mean only one user should ever have that value for a username or for a password. Yeah?
It should be the username.
OK, username. Why?
Because people, yes, because you only want one person with one particular username.
Perfect.
And passwords, well, you can't really tell people what passwords they should have. I bet lots of people have like hello or 1, 2, 3, 4.
OK, good. So username, it's reasonable to expect that really should be unique. Otherwise, consider the alternative, right? Consider on Facebook, if you could log in as J Harvard, but so could someone else, like whose profile are you going to see? So like that clearly needs to be unique. Now, password doesn't need to be unique, right? Because it'd be nice if we could have the same password. It'd be nice if it's not something silly like 1, 2, 3, 4, 5. But by chance, you have 500 million plus users, and 2 people are going to have the same password. So to impose that constraint seems a little foolish. Plus, if you really think about it, well, if you only had 2 users in the system and you try to choose a password and you're told someone already has it, you know the other guy's password, right? But that's a corner case. All right, so in terms of enforcing this, what can you do? Well, if you're writing code that registers users, signs them up for your website, you could just do it in PHP, right? You select, if the user wants to register as John Harvard with username J Harvard, you first check, does J Harvard exist? And how do you do that? You do a SQL select. And then if it doesn't exist, you get back 0 rows, then you do your insert. If instead you do see a J Harvard already, you just yell at the user and you say pick another username. Now, there is a problem here that we'll come back to next week, whereby what if 2 John Harvards are sitting next to each other or sitting in Starbucks halfway across the world from each other, but at roughly the same time, they both try to register for the site. So they type in J Harvard and then both hit enter at roughly the same time. Their post requests go to the web server. The web server processes them, maybe even in parallel, right? This is a multi-core computer, multiple CPUs. It has multiple threads. Therefore, literally, stuff can happen at the same time. And even if it can, suppose one of them gets in ever so slightly before the other, what might happen? Well, both of these guys' posts might be handled by the web server. The web server is going to treat them similarly, and it's going to do a select from the database to see if J Harvard exists. But then think about how computers typically work. You don't get 100% of the CPU's attention. It multitasks among all of the various threads or things going on inside of the computer. So right after your select statement for J Harvard, this thread, so to speak, might be put to sleep briefly, split second. But that means this guy might be woken up and his select statement gets checked. The answer now to both of these guys is J Harvard does not exist. So now your second line of code executes and you do the insert. Then this guy gets put to sleep just because of the way the operating system is behaving. This guy then tries to do the insert. What happens? It breaks somehow, right? Either you're trying to insert another J Harvard, and worst case, you now have 2 J Harvards, which is like the Facebook problem. Now, which is the right J Harvard, whose profile do you show, and so forth. Or there's a failure case, or somehow this guy's password is now the same for both people. In short, this is not a good situation. So we'll solve that problem next time with this notion of locks or transactions. But for now, this is kind of a bad situation. But this is where, too, databases are so much more powerful than XML files and CSV files, where the onus is otherwise on you. Here, we can tell the database, make the username field unique, so that even if I screw up, I being the developer, I can at least still have a defense in place. So I'm going to go to users. I'm going to click not edit, because edit would just edit my table. Instead, I'm going to click on structure at the top. And now here's just a reminder of what we did earlier. So I've got my username field, varchar, Swedish, and so forth. I'm going to go ahead and check all, and then click change. And now I'm just going to see, again, that form that we saw a while ago. So what do I want to change here? I'm going to scroll over to the side, and I'm going to change the oh, notice here, I can no longer do it here. I actually forgot. Can't do this here. So no longer do I have that drop-down that had uniqueness. And that's because the table already exists. So it's actually on another screen, and this is just a phpMyAdmin thing. It's not compelling for any other reason. And if I scroll down here, notice that next to username, I have a few options. So I have a add unique index, add index, add spatial index, add full text index. And actually, there's another way I can actually do this. If I instead go over here, I can check username, and then notice these icons here. I can check primary or unique. Frankly, this UI is a bit of a mess. But in short, I have a number of alterations I can now make on this field. So what do I want to say? I do want to say username should be unique. But there's a special word given for unique keys if those keys, or rather those fields, also are supposed to uniquely identify rows in your table. So in this case, username uniquely identifies my users, or should at least. So I could make a unique field by clicking where the cursor is now at top right, clicking unique. But technically in the future, if I'm going to use this field, jharvard, to uniquely identify users, this is by definition what's called a primary key. It is the key, the field, the column that you use to uniquely identify your users. Which is to say, your table can have other unique fields, even if you don't actually use them to identify your users. For instance, what's another field that in theory, only one user in the world should have one of? Phone number? Cell phone maybe, but some of you still have landlines, right? And families or roommates. What?
Social security number?
OK, so social security number. That is supposed to be a unique number per person. And so you might want to enforce that in the database. But frankly, not everyone in the world has a social security number. So you might want that field to be null. But when it's not null, you want it to be unique. So you can have the database at least enforce that. What about email address? Well, email address in theory should be unique, unless you're sharing an account or something. But it isn't necessarily what I want to identify my users with, if only because an email address might be this long. What would actually be a better data type to use in general for uniquely identifying rows in a table, do you think? What does Excel use? What's an index, though?
Just like a iterative number.
Yeah, I'll take number. So just a number, right? 1, 2, 3. Or maybe we start at 0. 1, 2, 3. So just a number. Why? Because then it's only 32 bits or 64 bits. So it's only 4 or 8 bytes. Meanwhile, my email address, it could be 10 characters, 20 characters even, depending. Social security number is similarly long with hyphens and whatnot. So in short, the best candidate for a unique key is probably not a string at all. So let's actually alter this table. I'm going to go ahead and before I change the key, notice down here I can make some alterations. I'm going to say add a column at the beginning of the table, although where it goes doesn't really matter, but it's common convention to put your primary key at the top at the beginning of your table. I'm going to click Go. This is going to allow me to add a new field, and I'm going to call it aptly ID. And I'm going to leave this blank, this blank, this blank. I'm going to leave this as none. I don't want a default value. And I'm going to go ahead and click Save. And now notice I have an int whose size or type is apparently 11. This is a legacy thing. This does not mean your integer can have 11 digits. It does not mean your integer can have 11 bits. It means when you are in this black and white window that we saw earlier, and you print out these old school looking columns like this thing here, that means your integer will use 11 characters in this black and white interface. So completely legacy. So it's pretty much irrelevant. 11 was just the default now. All right, so now I have some power. I'm going to go ahead and change this. I'm going to go ahead, whoops. Let me go back to my structure. I'm going to go to ID. And let's say, what do I want to do here? Change. I'm going to go to, why is it not letting me do? There it is. Change. Oh, I didn't scroll over far enough before. This was here. So AI. Does anyone recall what this is? Yeah.
Auto increment.
Auto increment.
I think it will, when you add another user, it's automatically going to be 2 if the first one is 1.
Exactly. So this is yet another feature of a database that's not just nice to have, it's really compelling. So if you want to uniquely identify your users as efficiently as possible, much like Facebook does with a number in the URL, unless you chose a custom username for Facebook, a number is the way to go. 32 bits, 64 bits, definitely nice and predictable instead of a variable length string. But you don't really want to be in the business, frankly, of figuring out what user ID is available, right? That too would be kind of annoying. If any time a user registered, you first had to figure out the highest number of the previous user's ID and then choose the next number by adding 1. It's not hard. I mean, it's trivial mentally to do that, but it's just extra work. Plus, you run into the situation what if two people try to register at ever so slightly the same time? You're going to get into this so-called race condition, but again, more on that next time. So I'm going to choose auto increment here because what this means is when I do an insert in the future, I am going to have the ID field automatically assigned for me. Now I can't just do this yet because notice incorrect table definition. There can only be one auto column and it must be defined as a key. We haven't finished that part of the story of making this a key. So rather than use username as my primary key that uniquely identifies my users, I'm instead going to say, you know what? ID will be my primary key. And this is the SQL query that was just executed. Alter table users, add primary key on ID. And now I'm going to go and change this field and scroll over to the side, make it auto increment and save. And now notice under the extra column, I'm just being reminded that this has the auto increment flag on it. And here's how this worked. Alter table users, change ID to not null auto increment. All right, so username. That still leaves the question of username. Should username have any kind of index or key? Well, do you want username to be unique? So we still do. You can only have one primary key, though. And we'll see why next time, too, why you want to have a primary key as opposed to just a unique index. But I'm going to go over here and say this should be unique. So now, watch what will happen. Whoops, my cursor is doing strange things. Here's browse. We only have one user. So let's try to insert someone else into the database, and we'll do it the real way with SQL commands. So insert into users, a username and a password. And I'll put my quotes around everything just for good measure. Also because password is a function, recall. The values of quote unquote Malan and 1, 2, 3, 4, 5, close quotes. And semicolon's not necessary here. It's only necessary in the command line client. So let's do go. OK, so that was inserted. If I go to browse now, notice I have two rows, Malan and J. Harbord. Now let's try to register Malan again. But notice one thing first. What was John Harbord's ID? And what was Malan's ID? 1 and 2. So exactly what Axel promised would happen. The nice thing here is I didn't have to think about that. I didn't have to insert 2 myself. I won't have to insert 3 myself. If it's auto increment, auto is literally the keyword here. It happens automatically for you. And you avoid this thing called a race condition, where two people might be registering at the same time and might otherwise, if I were writing the code, give them the same ID, which would be bad. So now let's test our uniqueness constraint. Let's go into SQL again, and let's do insert into users, a username and a password with these values, Malan and a password of 5555. So different password. All right, go. Duplicate entry Malan for key username. So what does this really mean? So this is an error now that's happened. So if you called MySQL query, you would actually be informed programmatically in PHP an error has happened, which is your way then of inferring I must have tried inserting the same username twice. So we now have this defense in place. All right, so this table's coming along, and it turns out that primary keys are going to have a relationship with something called foreign keys, but more on those separately. What else motivates this choice? What might you gain by telling the database in advance that this field is special, that this field is unique? What might that lend itself to, if that's not too vague? It's actually the answer to it's the same answer to every question thus far tonight. Yeah.
Maybe it has to do something with performance.
Yeah, performance. Good answer. So it does actually have to do with performance. When you create a index, as it's called, or key index, they're essentially referring to the same thing. when you create an index on a field, on a column in a database, the database is going to spend some effort, some time, and some disk space up front to optimize that column. And by that, I mean it's going to build up a secondary data structure, which is usually a data structure of a tree, a B tree, in fact, if you've taken a data structures class. And a B tree is essentially a very shallow tree that lends itself to searching large chunks of data, like you might have in a big database table. It creates this index, this B tree, that makes it much easier to answer questions of the form, who is ID 2? Or is J Harvard in this table? Any query you might want to ask about a specific field, in this case ID, or even the username field, will be faster. Previously, when we did the select star from users where username equals J Harvard, that was a linear search of the entire table. Now, you were not unimpressed because there was one person in the table, so it's obviously not that slow to search the table. But if we did have Facebook's 500 million plus or 800 million plus users, that would have been a linear search looking for John Harvard. Awful, especially for large data sets. Now, if you instead click that button and say, make this a unique index or make this a primary key index, then the database is going to churn through that list, and it will do linear search maybe once, maybe twice, maybe 3 times. But the output of that process is going to be some kind of tree structure that's kept around in RAM so that the next time you ask me a question, it's going to be much faster to answer the query. And it's going to do something like binary search or even something fancier than that. So indexes are huge. And if you've ever visited a really bad website in terms of performance, it's slow. Going from page to page has nothing to do with your internet connection because you're at home on broadband or whatnot. It's just a really crappy website. Odds are it has to do with, one, server could just be overloaded and they're too popular for their own good. Or very likely, they just didn't know what they were doing when creating their database tables. And they just created rows and columns like you would in Excel. But they gave no thought to primary keys, indexes, uniqueness, or anything like that. Full text is similar in spirit. It can be used for text fields. So here's one of these design trade-offs we didn't touch on earlier. Varchars are great for variable length strings. Text fields are great for variable length strings that are even longer. But you do pay a performance penalty because the text fields, remember, end up elsewhere, which just means they're not as local, caching issues, and so forth. But the upside of using a text field, which is bigger, is that you can put a full text index on it, which means you can do Google-like queries on the search saying, return this row if it has the keywords foo and bar and not Baz, or things like that. And you don't have to implement that yourself. The database can do it for you. The price you pay, though, is performance for just selecting the data potentially. So again, there's no perfect solution here. It really depends on the use case you're trying to solve. So let's consider a problem that we're not going to solve tonight, but that does kind of remain. Suppose we augment our users table to include not just username and password, not even just ID, but again, what are some things we might want to associate with a user? Axel?
Their email address?
Email address. Good. Give me something else. Yeah, Con. Phone number. Good. Something else. Gender. Good. Something else. We'll keep doing this until we get the answer I need to tell the story. Yeah. Oh, what's that? Pictures of the user. Good. Oh, actually, we can tell a quick story about this. How do you store binary data? So you actually can store in a database. And in fact, one of the fields that we didn't look at but was on the screen there briefly when you create a new field. Let me try to simulate it. Let me go to structure. Let me go ahead and add a new field and show the types. At the bottom here, there's some fancier features that we really haven't even scratched the surface of. Blobs. Binary large objects. And this just refers to binary data. So you could actually store photographs of users in the database, or you could store them on disk. And this is actually one of these other non-obvious design decisions, but this one, at least, there's some good rules of thumb. Frankly, I am of the philosophy that data belongs in a database and files belong on a file system. And by this, I mean if you are having your users upload photos or resumes or whatnot, storing them in the database is probably not the right place because the database is going to get bigger and bigger and bigger. I mean, files are generally much bigger than textual rows. And so you're going to run eventually into performance issues. You're going to run potentially into disk space issues. You're going to run into replication issues whereby very much in vogue these days are CDNs, content delivery networks, which are just servers like Akamai and Google and the like. And Facebook has this too. Hundreds or thousands of servers whose whose purpose in life is just to serve up static content, JavaScript files, JPEGs, PNGs, movie files, and whatnot, and that's all they do. If instead you're storing that data in a database, now you have to replicate your database around the entire world, and having MySQL databases here and here and here, which is totally possible, but completely unnecessary for scalability. So we'll talk more about this at the end of the semester, but in general, I think in like the past 6-10 years, I've never stored binary data in a database, really, at least not files. Better to store the file on disk in a folder, for instance, of uploads that's owned by you, a la SQPHP, which we talked about a couple times ago. But what could you still store in the database? The path. So you store the path or the name of the file that's uploaded. So you still associate the thing with the user, but you store it in a more natural environment that lends itself to scalability and access controls and the like. Now, there's some other cool ones. If you like things like geography and anything related to points and latitudes and longitudes, there's nice built-in support in MySQL for that kind of stuff too, where you can actually do queries like, is this latitude longitudinal point nearby this other one, and similar queries, which you would have to otherwise implement yourself in CSV or XML or any other domain like that. All right, so let me try to coax this last story a little further along. What else might you want to associate with a user? Address, there we go. OK, so address is interesting because it may be the case that you have unique postal addresses or home addresses unless you have a family or roommates. So there's some corner cases there. But let's start telling this story. So now John Harvard lives, for instance, at 33 Oxford Street, Cambridge, Mass. 02138. Suppose David Malan also lives at 33 Oxford Street, Cambridge, Mass. 02138. And so on, and so on, and so on. What's the redundancy there in particular? Yeah.
You're storing the same string or whatever multiple times.
Exactly. What string is really redundant here? Or what strings, Jack? Cambridge, Mass. Why the heck am I storing Cambridge, Mass, Cambridge, Mass, Cambridge, Mass, Cambridge, Mass again and again when really I could identify Cambridge, Mass by what? By zip code. Now, as an aside, the US is kind of a mess with its zip codes, and over time I've learned that zip codes actually don't always follow town boundaries, and there can be weird overlap and so forth. So this is a nicer story than it is actually in practice. Sometimes towns share zip codes and vice versa. So kind of a mess, but that's the human's fault, not the computer people's fault in this case. So let's at least assume that zip codes do uniquely identify cities and states. So this is great, because I can store 5 digits, a char field even, 02138, and then how do I remember that 02138 maps to Cambridge, Mass? Jack?
Is there another database somewhere that has all of the areas that have existed or been put up on your server?
Yeah, exactly. So you can buy off the internet a big database of zip codes with city-states. So you could just buy that or find it somewhere. And then you could store your own local copy. Because what you can do with MySQL, even though we haven't done it yet, is you can have more than one table. Right? Just like Excel can have multiple worksheets. MySQL can have multiple tables. So I could have one table called users and another table called cities or another table called zips, whatever I want to call it. And what would the primary key be in the zips table? And what would the columns be? Yeah. Yeah, probably the zip code. Could be a unique number, like an integer, but if I already have a number and it's a fixed length, like this is actually a pretty good candidate for a primary key. So what else would be in the zips table? Yeah, city and state. And I could push a little harder. I could factor out anyone who has 33 Oxford Street somehow. But frankly, storing the street address redundantly is probably OK. Storing city-state again and again and again doesn't feel nearly as OK. Because right, how do I uniquely identify 33 Oxford Street? I have to standardize on a name for it, like 33 space OXFORD space. We'd have to make more of a design decision there, whereas at least with city, state, and zip, that in theory should have a nicer relationship. So I can factor that out. So now the issue of primary key should maybe make a little more sense. Now we can have a zips table whose primary key is zip code and whose other columns are city and state and so forth. We can then have my users table, and we add another column to it called zip. And what do I store in the zip field? Well, something like 02138. At that point in the story, 02138, or more specifically zip code, is a primary key in the zips table, and it's what's called a foreign key in my users table. So this, too, is why it's advantageous to define these kinds of keys. Primary key, again, means uniquely identifies rows in this table. Foreign key means is a primary key in another table. And what this will allow us to do is take the users table, take the zips table, and if I want to see all of that data together, I want to see J Harvard, Crimson, 02138, Cambridge, Mass. I want to join all of that information together so I can get at it with one associative array, one MySQL select, MySQL fetch assoc call. What we can do is if the rightmost column of this users table is zip, and just for the sake of pictures, the leftmost column of, it's the opposite to you guys, the leftmost column of the zips table is zip. Right? So we have zips, zips. We can effectively overlap them and join them so that now we have a wider table that has all of the data we care about. Redundantly, but at least now it's a temporary table. So this refers to generally the process of normalization. And factoring out data that would otherwise be redundant is not necessary to keep. And this is the bread and butter of relational databases. You put as little information as you need to solve the problem in a given table. You factor out as much as you can, and you leverage a feature of SQL known as joins to actually rejoin the data later, which even though it costs you a bit in CPU cycles, saves you significantly in space, especially when you have many, many, many users. All right, any questions? All right, why don't we go ahead and call on Luis? Luis?
When we were doing the project, so my phpMyAdmin that's in the appliance, is there any other I guess GUI that we can use, or we have to use that because that's already in the
It's in the appliance already. If you're running Windows, there is a Windows MySQL client that you can download somewhere on mysql.com. You would then configure that Windows program to talk to the IP address of the appliance with username jharvard, password crimson, and you could use that as well. To be honest, I would even though I have my qualms with its UI, it's actually a wonderfully useful tool that just gets the job done. And it's not, again, a key part of the project. It's just a user-friendly way of getting at the data and creating tables and such.
We can use any method to create the database.
Yep, absolutely.
More of the PHP that talks to it.
So exactly. So at the end, well, and actually for Project 0, you don't need MySQL at all. You don't need phpMyAdmin at all. So this will only be relevant next week for Project 1, which will actually use MySQL. But at that point, you're welcome to use any development environment you want, any tools that you want, so long as we say in the spec, your code works properly when you install it in the appliance so that when we and the teaching staff install it in our appliance, it's guaranteed to work. And it's not tied to your random PC configuration or Mac configuration. There's at least a standard installation setup. Let's adjourn there. I'll stick around for one-on-one questions. Otherwise, Malan will start with section in just a little bit. See you on Monday.